Hi there. Senior Technical Specialist Stephen Rosell here. I am going to pick up where I left off in the Bifrost Basics demo series. And we're going to talk a little bit about compounds. Now, we finished part 3 with an introduction to compounds. We're going to talk a little bit more about that and what you can do with them in terms of saving outside of Maya and reusing them. So what you'll see here is I've got a simple deformer that I've created in Bifrost as a series of nodes and connections. And it's creating this kind of noise deformation. And I'm using color per vertex, the red channel actually of the color per vertex, to mask that out. So if I add white over here, then it's going to add deformation. If I remove the white, then it's going to remove the deformation. So basically black is 0 and white is 1. So what I want to do now is take all of this and make it reusable in another scene or for another user. So a couple things to point out. I've got an input node here, the torus, which is the mesh that I'm working on. And then I've got an input node here, which is hooking up to a couple of different things. One is the magnitude of the noise node. I'm using a fractal noise. And the other, speed, is actually doing a simple scale, a simple multiply on time. So that's really all I'm controlling at this point. I could obviously have more inputs than that. And I've got a single output that is basically outputting one mesh. I could have multiple outputs, but in this case, it's just that one output. So what I'm going to do is I'm going to grab everything in between the inputs and the outputs, and I'm going to select and Control G. And what that will do is it will compound that. It will basically consolidate everything into a single node, and it will create inputs and outputs. If I double-click on this, then I can dive in, and I can actually look at the underlying structure. You'll see that I've got an input and an output, which corresponds to the input and output connections here. Now, before I go any further, what I might want to do is kind of organize this a little bit. So I may want to reorder some things. So I'm going to take the speed attribute, for instance, and I'm going to, let's just say, move that up. So I'll move that up there. I may even want to take it up one more notch, like so. So the mesh is the last input. And I might want to do a little renaming. Right now I have mesh in and out geometry out. Let's simplify that, and let's just call that out geo. And likewise, let's come in here and rename that and call this in underscore geo, just so it's consistent. Last thing I want to do is name the compound itself. So I'll rename this, and I'll just call this my noise deformer. Now, all I've done here is basically organize it within the existing scene, but this is not usable outside of the existing scene that I'm working in. So we're going to make this shareable now. So as you'll recall, if I hit the tab key, I get a list of all the possible nodes that I can use. So I've got all these different categories of nodes and subcategories of nodes. I've also got this section here that says user. And in there, I've got the ability to save my own kind of custom compounds, my own custom node networks that I want to be able to reuse for other purposes. So I'll just simply grab my noise deformer compound, and I will publish this. And when I publish it, I have the option of putting it into a namespace. And what this will correspond to is basically the categorization or the kind of the folder structure of that compound library. I can give it a different name. I'm just going to use the default name here, and I will publish. Now what that will do is it will save out a JSON file, which is essentially a text descriptor of this node network. So it's called my noise deformer. If I go down here to search now and I do a search for my noise, sure enough, there's a file called mynoisedeformer.json. If I open the file location, there's the file. If I open that, what you'll see is a JSON file, which is a text description, or for lack of a better word, a recipe for how to rebuild this node network. So if I scroll down, you'll see that in here I've got the name. So there's my noise deformer and the name of the file, mynoisedeformer.json. If I scroll down a little bit more, I've got information about things that are input and output, like speed and strength and NGO. And if I just keep going down even further, I'll start to see information about the contents. So for instance, I used a node somewhere along the way, vector4 to scalar. Now that's one of the built-in base nodes, but that's basically the point at which that node gets built. So again, it's a recipe basically for essentially rebuilding this exact node network. So what the contents of this are described in text in this lightweight, portable format. So now what I can do is I can basically just drag and drop that or import that right into a scene, and I can reuse it. So now we're in a new scene, and all I did was I went to the content browser and I just chose one of the generic meshes that we provide as, you know, one of the sample models. And I picked the horse, and I went in and I painted some color per vertex. So obviously here the head is white and the rest of the body is black. So all I need to do now is go to the compound editor, create a new graph, and what I want to do is basically take that horse and create the input for the horse, and I want to feed that into my noise deformer. So I just simply hit the tab key, type in my noise deformer. There it is right there. And now I can just start to hook things up. So I can use the original input node to drive the speed and to drive the strength, and I can take the output of this node, which is the horse, feed that into the geo, and then I'll output that, and that will, of course, generate the mesh right back into Maya. Now, the thing is, if I push play, nothing happens right now because I don't have any values set. So I hooked up connections for the input of speed and strength, but I haven't actually changed them. By default, it's going to zero out. Unless that node is already there, by default, that's just going to be 0. But let's set this to be something like 0.1, and now when I play this back, sure enough, I'm going to get a nice-looking deformation, kind of a silly-looking deformation, but a deformation nonetheless on the horse. So now I can go in and I can start to accelerate this. I'll grab my input here. I'll say I want to set, let's just set that actually to 1. I'll set the speed to 1, and now you can see I get a really fast deformation. Dial that down to 0.5 maybe. The strength, I can blow that out and get this crazy deformation, or maybe somewhere in between. Actually, probably want to get it nice and light there, something like that. Now I get this kind of jittery effect, and if I turn on the wireframe, it'll be a little bit easier to see what's going on there. Let's amp that up just a little bit, maybe make that 0.05. There we go. And the cool thing is that it's using the vertex color. So if I were to go in and grab the horse and go into my paint vertex color mode, and let's just say I wanted to paint on the feet here. Now as I start to paint on the feet, you can see that foot will start to jiggle, and I'll smooth that out there and smooth it out there. And now I've got a jiggly head and a jiggly foot. So that should give you an idea of kind of how these compounds work. Again, it's all lightweight and it's all text-based. So once you have these descriptors written, you can actually edit them easily from the text file. So for instance, if I wanted to change the input attribute here, I can from the text file. So I'm going to talk about that in the next demonstration. We'll go over how these compounds are basically used from within Maya. One other thing to point out, if you're going to do this exercise on your own, and it's something that I forgot actually when I was redoing this, is that in order for this to work, you have to have the right color name. So if you dive in here and I take a look, remember I'm getting the red channel. I use that compound to create the red channel, and I use this getGeoProperty node to define the attribute that I'm looking for. So I'm taking the geometry pipe and I'm stripping out the myColor attribute, or data rather, which is a vector 4, and then downstream I'm separating out, using a vector to scalar, I'm separating out just the first attribute or first channel, so the X is equivalent to the R. The reason I'm saying that is because if you just paint vertex color by default and then hook your mesh up into this, it's not going to work unless you rename your color set. So you can paint your colors and then go to the color set editor and just make sure myColor is the appropriate name. Now, there are all kinds of tricks that you can do to do checks along the way. So for instance, what you probably want to do is check to make sure you have vertex color first, and then if you don't have it, then just apply the deformation to the whole mesh. And you might want to check the name to make sure the name matches color, myColor, and if it doesn't, then you would just apply it to the whole mesh. Because right now, if the color name is not correct, in other words, if this was just called XXX for lack of a better word, then it's not going to work. All of a sudden, my mesh is going to disappear because the data flowing through this pipe changed. So the geometry was carrying, in fact, we can even put a watch point on this. I'll go up to the top, and we'll actually look at the input node here. If I put a watch point on this, I'll explain that in the next demonstration, what has just happened. But for now, let's just move on, and I'll show you that if I put a watch point on this, sure enough, the color that's feeding through here is the color channel, the color set is XXX. And this node network doesn't know what to do with XXX. It's looking for something called myColor. So like I said, if you were really going to build this in a more robust way, you would put checks, you would put conditionals in there to make sure that the color set is there, to make sure that it's named appropriately. In the case of a simple demonstration like this, I'm not going to go that deeply, but what I can do is just go in here and just change this back to myColor. As soon as I change this, bam, that's going to update. You'll see down here, myColor is now flowing through this pipe. You can see right there, and as a result, it's going to work correctly because the appropriate data is now flowing through in order for that noise deformer to work as expected on it. So we'll leave it there, and then I'll come back later and I'll talk to you more about how to go about referencing compounds versus creating unique instances of compounds. Thanks for your time. Bye.